Now, in this video, we will going to discuss about the generalized Hooke's law. So here you have a volumetric bar, which is a cube having the normal stresses in x, y, and z direction, sigma x, sigma y, and sigma z. When a body is subjected to a normal stress in three mutually perpendicular directions, net strain along x direction, x axis, will be equal to the longitudinal strain during sigma x acting along x direction. So that means net strain along the x axis is the longitudinal strain along the direction of x. Lateral strain along x axis due to sigma y along y axis. So then lateral strain along x axis due to sigma z along the z axis. So we have the longitudinal strain x lateral along x, y, and lateral strain along y and z axis. So longitudinal strain along x axis. Now when you are considering that, two important relations used in finding the net strain along x axis are, one is the Hooke's law. So then the other one is the Poisson's ratio. Why? That is because we have the longitudinal strain and as well as the Poisson's ratio. So what is according to Hooke's law? Young's modulus is stress by strain. So that is linear or longitudinal stress by the linear or longitudinal strain. So what is that? Sigma by epsilon. So what is the longitudinal strain? So the longitudinal strain by sigma by E. So the ratio of lateral strain to the longitudinal strain is nothing but the Poisson's ratio and is a constant within the elastic limit. So what is 1 by m? It is the lateral strain by the longitudinal strain. So epsilon lateral by epsilon longitudinal. So what is lateral strain? Which is 1 by m into epsilon longitudinal. If you are considering that. So what is the longitudinal strain along x-axis due to sigma x? So what is that? Which will going to be sigma x by E. So positive because we have the tensile stress. Because the normal stress what is acting is along the x direction. So naturally since you are taking the x-axis, so along the direction of x-axis, so the sigma x will be positive because it is the longitudinal strain, which is tensile stress. So when you are taking the lateral strain along x-axis due to sigma y, so what is the combination of effect due to the normal stress along the x-axis? Naturally, the lateral strain will going to be, that is the width and thickness will going to be reduced. So obviously, it should be negative. So minus 1 by m into the longitudinal strain along y direction due to sigma y. So that is equal to minus of 1 by m into sigma y by E. So what is sigma y? Minus sigma y by m into E. So negative because it is the tensile. Since sigma y is tensile stress, so that is the negative because we have that the lateral strain which is going to be reduced. So lateral strain along x-axis due to sigma x, which will be equal to again minus 1 by m into longitudinal strain along the z direction. So that is minus 1 by m into sigma z by E, that is equal to minus sigma z by m into E. So again negative since sigma z is in tensile stress. So what will going to be the net strain along x-axis? Epsilon x will be equal to, we have sigma x by B minus sigma y by m into E minus sigma z by m into E. So we are going to substitute all these values. So that will going to be sigma x by E, that is 1 by E, you can take out the common factor. So net strain along y-axis which will be equal to epsilon y. So in such case what happens? Epsilon y will be net strain along y-axis. Now since y-axis is the one which is considered, so you will going to have a longitudinal strain along y-axis and the lateral strain along x and z. So sigma y by E minus sigma z by m into E by sigma z x by m into E. Similarly, net strain along z-axis, which is epsilon z, which will be equal to sigma z by E minus sigma x by m into E minus sigma y by m into E. So that is what we are going to get. So when you are substituting, so when you are considering this, so this is the all the different types of strains which is acting along the x, y, and z directions. Now we will going to consider the volumetric strain due to three mutually perpendicular stresses. So what is that? volumetric strain on three mutually perpendicular stresses, that is L, B, and D. Consider a rectangular block subjected to three tensile stresses, which is sigma x. So this is the sigma x what you have, that is again tensile. Sigma y, which is along the y direction, again it is tensile. Sigma z, again it is tensile. On three mutually perpendicular planes, that means you are going to all the three are mutually perpendicular to each other. So here length is in x direction and thickness, that is depth, is in y direction, and width is in z direction. Now what is the volume of the block? L into B into D. So if you are considering that, taking the log on both sides, we have log V, which is log of L plus log of B plus log of D. So by differentiating, what we are going to get, 1 by V into delta V is equal to 1 by L into delta L plus 1 by B into delta B plus 1 by D into delta D. So where delta V is the change in volume, so delta L is change in length, delta B is change in width, and delta D is change in thickness. So what is epsilon V? Epsilon V will be equal to epsilon x plus epsilon y by plus epsilon z, where epsilon V is the volumetric strain. So the tensile strain in the tensile stress in the direction of xx is sigma x. Similarly, tensile stress in the direction of yy is sigma y. And similarly, tensile stress in the direction of zz is epsilon z. Now what happens? Sigma x will produce tensile strain, which is equal to sigma x by E in the direction of xx. So compressive strain along sigma x by M into E in the direction of yy and zz direction, because that will be decrease in width and thickness. Similarly, sigma y will going to produce the tensile strain, that is sigma y by E in the direction of yy, and compressive strain, it is sigma z by M into E and sigma x by M into E in the direction of zz and yy. Similarly, sigma z will going to produce the tensile strain in sigma x by E in the direction of zz, and compressive strain in sigma z by M into E in the direction of in the direction of xx and yy. So hence, by the generalized Hooke's law, what happens? Total strain will going to be the longitudinal strain in the direction considered plus sum of the strains, that is the lateral in the remaining two directions. So naturally it becomes compressive there. So total strain in the direction of xx, which is epsilon x, will be equal to sigma x by E minus sigma y by M into E minus sigma z by M into E. So again, total strain in the direction of yy will be equal to sigma y by E minus sigma x or sigma z by M into E minus sigma x by M into E. So similarly, lateral strain in the zz direction will be equal to epsilon z, which is equal to sigma z by E minus sigma x by M into E minus sigma y by M into E. So this is how you are going to be able to get this. So on epsilon b, you substitute the values of epsilon x, epsilon y, and epsilon z. So that is sigma x by E minus sigma y by M into E minus sigma z by M into E, plus similarly sigma y by E minus sigma x by M into E minus sigma z by M into E. Similarly, sigma z by E minus sigma x by M into E minus sigma y by M into E. So once you consider that sigma x by E plus sigma y by M into E, sigma y by E plus sigma z by E, segregate these considerations by rearranging the above equation. You will going to get it like this: sigma x by E plus sigma y by E plus sigma z by E minus 2 sigma x by M into E, because you have sigma x by M into E here and minus sigma x by M into E. Adding these two, because this is also negative, this is also negative, minus 2 sigma x by M into E. Similarly, here also you have minus sigma y by E minus sigma y by E. So you're going to get minus 2 sigma y by M into E. Similarly, you have minus sigma z by M into E and minus sigma z by M into E here. So both these two, when you add, minus 2 sigma z by M into E. So what happens? You take out sigma x by E plus sigma y by E plus sigma z by E minus 2 by M into E into sigma x plus sigma y by sigma z. Then similarly, you take out sigma x by E as the common factor. sigma x plus sigma y plus sigma z by E as the common factor, because you have in the numerator here sigma x plus sigma y by sigma z. Similarly, sigma x plus sigma y plus sigma z. So you take out that and you have all E in the denominator, and here also you have the denominator. So sigma x plus sigma y plus sigma z by E into 1 minus 2 by m. So therefore, volumetric strain epsilon B will be equal to sigma x plus sigma y plus sigma z by E into 1 minus 2 by m. If sum of these stresses is equal to 0, so sigma x plus sigma y plus sigma z is equal to 0, then epsilon B is equal to 0, then there is no change in volume. So this is how you will be able to get the volumetric strain. Thank you.